Hi, everybody. My name is Anna, and it's wonderful to be here. I'm here today as a representative of the Northwest Avalanche Center. Just briefly about me and my background. I'm a mountain guide year round, and for me, that means in the summer I take people up the mountains, mostly in Washington. To the summit of Rainier and Baker and Olympus and Glacier Peak and Shuxon. Um, I also teach a lot of mountaineering classes, so I'm engaging with snow and avalanches a lot in the spring and the fall as well in the mountains. And then in the winters, I teach a lot of avalanche classes, and most of those are the AIRE Level 1 class. And if you don't know what that is, then I will be talking about it at the end of this as possible next step for folks. I also teach the Pro 1 avalanche classes for aspiring or new professionals. And then I teach a lot of these. So my head is engaged in snow all year and talking about avalanches, and I love it. It gets me excited. So I'm excited to be here, and I'm glad you are all here as well to learn about avalanches this evening. Um, this presentation was made by the good folks at the Northwest Avalanche Center, and I go through it. This is, I think, the fourth time I've made this presentation this winter, so bear with me if anything funny happens or I forget what's on the next slide, but generally it's a really good presentation that I think they did a great job on, so it flows pretty well. One thing I appreciate the comment about leaving your video on if you're able and willing, but I also totally respect if you choose to have your video off for any reason. So I see something in the chat. All right. Um, I also, while I'm talking, I'm just going to basically talk for the next hour straight. And I love questions and I encourage questions. And so the way that I would appreciate that you ask questions is by using the hand raise function. Um, so I actually honestly am not totally sure how the hand raise function, how you can raise your hand. But it is an option at the bottom somewhere. I'm just always the presenter. I never have to raise my hand. So um, there is a way to raise your hand. And if you can't figure out how to raise your hand, I am also totally okay with you just unmuting and interrupting me and saying, oh, Anna, I have a quick question about what you just said, or it made me think of something else. So that's totally fine. Another option is to wait until the very end of the presentation, and there's going to be, obviously at the very end, I'm always like, uh, does anyone have any questions? So that's what you can kind of expect. About
Just
one
real quick,
hour.
guys, that hand raise is under that little heart that says react. You press the little up caret and it's an option right there, just so you guys know.
Oh, I think because I'm sharing, I don't see that. So thank you for, yeah, I don't have that option. So thank you. I can't react to myself, I guess. All right, so I'll just go ahead and jump in. And actually, we're going to start here by requesting that you take just a minute to use this QR code to fill out a quick form. So if you open the camera on your phone, point it at this, you should be prompted to open the website that will take you to a form. And we really value and appreciate you doing this. It will take you, it says take 2 minutes, but it usually takes people less than that. And NWAC uses the information and the data that we get from these forms to help continue to tailor these presentations so that we're actually meeting our audience's needs. So I'm just going to pause for 1 minute and let folks fill this out.
Can you share it again?
Share.
The QR code, can you share that again?
It should just be that QR code on the main screen that she's sharing right now.
Yeah.
It looks like there's several people who, including myself, that are on their phones, so we can't.
Oh, yeah, that's fair.
Can we do the QR after? can we post it to our groups and have people fill it out after?
If yes, I'm also like rapidly troubleshooting this problem. This right here is a good lesson for me because it's not uncommon for people to be on their phones. Okay, so
I just saw a comment to screenshot it and then maybe do it later. I don't know if that'll work or not. Screenshot the QR code.
Oh,
I'm
that's a
gonna
good-
drop the link to the form in the chat. It's just gonna take me 1 second.
Someone actually already did drop the link in the chat.
Okay, perfect. It's taking me too long. Thank you for doing that. Okay. If you're just wrapping up that form, that's great. Thank you so much for your patience in allowing us to troubleshoot that. I'll have that link on the ready the next time I do this. So continuing back, here big picture are some things we're going to chat about tonight. We're going to go over some basics of what avalanches are. We're going to talk about how do I know if there is a risk of an avalanche where I want to go. We're going to talk about how do I avoid avalanche terrain? And then lastly, what are maybe some next steps for you after this presentation? So to start, we'll dig right in. And as you probably know, avalanches are potentially life-threatening hazards that can happen on snow-covered slopes. We'll talk a little bit about what causes them and where they happen. So if you think about the definition of an avalanche is snow falling down a slope. It really is that simple. But the reason it happens is because snow is not uniformly distributed over the ground. And sometimes there's an avalanche hazard and sometimes there's not. So we're going to talk more about, weak snow, strong snow, and what that means. But in its essence, anything we call an avalanche is straight up just snow falling down. Looking at kind of a small avalanche here that left behind what we call a crown, where the snow pulled away from the snow above and fell down the slope. So here's another picture of an avalanche. This snow slid off of a roof, but even though it slid off a roof, it's still an avalanche because it's snow falling downhill, right? Here we have the remains or the debris of a really large avalanche that came down and covered the road, and now it's taking heavy machinery to clear it off. So avalanches can be all different shapes, all different sizes, but essentially if it's snow falling downhill, it's an avalanche. Back behind this green roof, we see what you might think is just a slope with some snow on it, but in fact, it's a very, very deep avalanche pile. So again, just snow falling down the hill. All right, so this is not a mistake. There's a picture of a cake here on purpose. And that's for us to start wrapping our head around what the snowpack is like. So when we're out walking around on the snow, it might be 2 feet deep, or it might be 6 feet deep, or it might be 12 feet deep. It doesn't matter how much snow there is between our feet and the ground. It's full of all these different layers. It's not just an identical uniform thing from our feet down to the ground. There's all these different layers and what we call interfaces which is where two layers touch. So this pink layer that's touching the yellow layer in this cake, where that pink and yellow layer touch, that's called an interface between two kind of separate layers. So these layers are formed from the weather. And here's an example of a snowpack that we might have. If we're out walking around on the top of the snowpack, we might not even be thinking about what's under our feet. But in this example, we have the ground at the bottom, and then we had a storm that came in very cold. And so most of us probably know that when it's cold outside, pretty cold, and there's snow falling, that snow tends to be really light, super light and dry and fluffy, low density. You know, if you're a skier or a snowboarder, you might call it blower pow or something like that. Colorado cold smoke. There's all these words that we already know about snow. So we have this low density, you know, light cold snow. And then we get 1 week of sun, and you might start to think about what the sun does to the top of the snow. Can kind of melt it a little bit. You know, the solar radiation, sun feels nice and warm to you, so it also feels nice and warm to snowflakes. You can kind of melt that snow, and then maybe it refreezes at night, so you might get kind of a crust on top. And then we have another storm where it's snowing, but it's really warm. The temperatures might be 31 degrees and it's snowing, so the snowflakes are coming in really wet, a lot of moisture. So we might think of that snow, we might call it heavy. I think of it as good snowball snow, that warm snow, wet snow. It's really good for making snowballs. So we have this warmer snow sitting on top of this colder snow. Then there's a day before storms. We get another cold storm, a long cold dry spell, and then it comes in really big and cold. So kind of like that layer cake we were just looking at, you can think of all these different layers under our feet inside the snowpack. All right, and now, just like we're looking at the side of that slice of cake, we're actually looking at the side of a slice of snow that's under our feet. And in this picture, they're pointing out there's a layer that it was interesting them, and we called it an interstorm layer, which just means that sometime during a storm, there's kind of a difference in layers in there. And then down lower, a lot of the time when people talk about the interfaces between two layers, they'll call it an interface, right? And they always give it a date. So on March 31st, it started snowing again, and now we have this interface that we'll call the March 31st interface. So just to tie that back in with this picture, let's say that we had this cold storm number 3, we had a long cold dry spell, and then on March 31st, we got another big cold storm that piled up on top of that. And now in between those two layers, we have an interface that we might call the March 31st interface. So just starting to think about how, you know, we think about and talk about what's going on down there inside the snowpack. Another thing to think about is that we talk a lot about snow as being weak and strong. And over here, this yellow bubble on the right reminds us that snowpack layers vary in their strength. So we can have weak snow and we can have strong snow, all, you know, in different layers underneath of our feet. So we're going to talk more about that. So here we're seeing that March 31st interface. They pointed out in the last picture, they're calling it a crust here. And then they're saying, you can kind of see this line in the white snow here where this block on top wanted to slide off of it. And they're calling that a common failure layer here because they're finding that when they do these tests on the snow, that the snow on top wants to slide really easily on the snow below it. And so they're kind of identifying an avalanche problem by digging around with their shovel and poking around and looking at these different interfaces inside the snow. So all of the, just keep in mind, like the big takeaway here is that all of the differences between the layers is what can lead to unstable snow and lead to avalanches. All right, so you don't have to identify unstable snow because in a few minutes, we're gonna learn how to find the avalanche forecast and start practicing interpreting that avalanche forecast in a way that is useful for us to go out and play in the snow and do it while we're avoiding avalanches. So we like you to kind of comprehend what's going on in the snowpack, know what unstable snow means, but you don't have to identify it. You don't have to go out and dig to try to figure out what's going on, because luckily we go out primarily in the Pacific Northwest. When we go out, we're recreating in areas where we have an avalanche forecast at our fingertips. Okay, so we're zooming back out a little bit here. Next, we're going to start thinking a little bit about why avalanches happen. And just remember that avalanches need to be set off by a trigger, and the trigger can be natural or it can be human. And what I mean by a trigger is that we might have weak snow sitting on the slope, but it might just sit there forever, and or over time it becomes stronger and the problem goes away. But if there is weak snow sitting there, something has to kind of cause it to fall downhill. And unfortunately, in over 90% of avalanche accidents where somebody is involved in being caught and carried in an avalanche, over 90% of those accidents, the trigger was another person or that person. So it's either the person caught or another human that ends up triggering that avalanche in over 90% of avalanche accidents. So it hopefully, that might sound scary at first, but it's also empowering to know that if we can just figure out how to stay off of steep slopes when there's a weak snow, then, we can avoid avalanche accidents. So here's another picture of a person. You can see a little black speck down at the bottom, and they were going so fast that they came over this steep roll and triggered an avalanche, and they were already pretty well below this big slab of snow that was starting to slide. And so unfortunately, this avalanche is going to come down on top of them because they're moving pretty fast. But you can see that this person was the trigger in this avalanche. It's pretty apparent. Okay, zooming back out. And now we're going to talk a little bit about where avalanches can happen. They occur on and below steep slopes. Any slope steeper than 30 degrees has the potential to avalanche. So when we think about where avalanches can start, they have to be slopes greater than 30 degrees. It's a little bit of a magic number because slopes that are less than 30 degrees are just too flat, and it's just because of gravity and friction that snow can't really slide down the hill. There's some like really tiny, rare exceptions to that rule, but generally speaking, slopes over 30 degrees are steep enough for if you put weak snow on there, it just generally wants to fall downhill. It just needs a trigger. The basic shape of an avalanche path includes the start zone, the track, and the runout. And this is true for all avalanches, regardless of kind of avalanche or size of avalanche. But when you look at a picture like this, the avalanche path is often really obvious. Like the slope up at the top was really steep, this big steep bowl. And if that snow starts to fall downhill, it's going to continue through the slightly lower angle terrain below it. But then once it starts to hit slopes below 30 degrees, it might start slowing down, but it's got a lot of speed by that point. So it kind of slows down, and then you can see the run out of the what we call the avalanche debris pile at the bottom. So this is a nice picture of a really clear start zone, track, and run out, which is the anatomy of all avalanches. And in the next picture, we see an avalanche, and you can see the line that indicates the edges of the slab avalanche that fell downhill. But maybe this isn't as clear as the last picture. Like It's kind of a blurry line between the start zone and the track. And we can't even see the run out here. It probably runs into those trees. So they can vary a lot in shapes, in size. So we look at this picture, and now we're getting to the point where your brains are probably starting to train your eyes toward, well, where do I think an avalanche path is? Where do I see a start zone? Where do I see terrain that's over 30 degrees? And so you possibly were looking at most of this terrain inside the orange circles here. And then there's a lot of terrain as well, primarily in the trees in this photo, that is less than 30 degrees and is therefore not somewhere an avalanche would happen. Here's another one. You start to get in the practice of training your eyes toward where avalanche terrain is, because knowing where avalanche terrain is an important thing in order to avoid avalanches. On a day when we know there's unstable snow out there, we want to be in the habit and the practice of identifying those steeper slopes so we can stay off of them. And you may very well have trained your eyes toward these obvious paths in the back, but there's these little orange circles in the front and off to the far left, just to kind of remind us that, this picture is taken from pretty far away, but indeed there can be small patches where the terrain is over 30 degrees and we might still be exposed to an avalanche. The last thing to remember is that some terrain features called terrain traps can make getting caught more consequential. So in this picture, there's actually what we call a crown up at the top of the rocks, again, where that snow pulled away and fell downhill. And you can imagine if you were to be pulled downhill in this avalanche, you wouldn't just be sliding down a smooth slope for 50 feet. It would be a lot more consequential. So again, we have this phrase terrain trap. It's a very important concept to be aware of because it's anything that can make something that might seem like a small avalanche a much bigger deal and cause more injury. So cliffs and rocks are a terrain trap. Another kind of terrain trap, so the last one we talked about, trauma, basically. But in this picture, it was probably a pretty small avalanche, but it piled up inside this gully. And so maybe on a different slope, that wouldn't be enough snow to bury a person. But with these terrain traps where the snow buries up more deeply, now maybe it is enough snow to bury a person. So like the last slide said, a terrain trap just makes getting caught more consequential. And that could be going over cliffs and rocks, or it could potentially just be that debris pile is deeper. Flat ground is another place where the snow piles up more deeply. And I'm guessing that some people in this class have been up to Paradise at Mount Rainier. I go up there in the winter and I like to go out what they call the fourth crossing road because they don't plow it in the winter and you can walk along. And that is a very common, very popular place for people to go walk, but it's right below a lot of really steep slopes. And I've been out there when a lot of that snow has avalanched and piled up really deep on that flat road at the bottom. So if you ever do venture out to Paradise again and you're wandering down that road, remember to think to yourself, did I read the avalanche forecast as I walk on this terrain trap below these steep slopes? Trees are another one. Not only can getting pushed through trees cause trauma, but if you get pushed up against a tree, the snow can also pile up more deeply behind you to cause burial. And lastly, trees sometimes have the tree well, where the snow around the tree is so much softer and lower density than all the rest of the snow. So sometimes people will fall into these tree wells and in an avalanche and get buried more deeply. So trees are definitely a terrain trap. All right, so big picture, avalanches occur. They will start, the start zone as we call it, is anything over 30 degrees. And we are going to dig a little bit more deeply now into this, where can avalanches happen, because it is, as I mentioned, a really critical component of avoiding avalanches is knowing where they can happen and where they can't happen. So we just want you to practice, to show you how you can practice this a little bit more. So, right now we're going into where can avalanches happen, and what we call this is avalanche terrain. And in order for an avalanche to even be possible at all, not only do you have to have a slope over 30 degrees that the snow can fall down, you also have to have unstable snow. So I've talked a bit about weak snow and strong snow, and you can have a really steep piece of terrain. You could be standing on a 40-degree slope, jumping up and down, but there's no weak snow. There's no avalanche hazard. So there are days like that out there. So you have to have steep terrain, you have to have unstable snow, and you have to have a trigger. And just remember that you're a trigger. You can't control unstable snow, but what you can control is avalanche terrain, whether or not you choose to go in it or choose to go underneath of it in the run out. So we'll focus on avalanche terrain because that's the one thing that we have control over. So here's a nice image of that 30 to 45 degree angle we've been talking about. And this is where the majority of avalanches happen. The reason is that, we talked about why they don't happen under 30 degrees, but over 45 degrees, it's steep enough that as snow falls on that terrain, it tends to fall off of it more frequently. It doesn't stick and pile up. Excuse me. So when you get weak snow landing on these steeper slopes, it tends to just slide off more frequently, slough off. So like maybe lots of really, really small sloughs and slides, but generally it just doesn't stay there long enough to pile up and become an issue, to become much of an issue. So avalanches can happen on any slope steeper than 30 degrees. They occur most often between 35 and 45. And you can measure slope angles with a tool called an inclinometer. All right, here's our first exercise picture. We see this terrain and we want to think, can an avalanche happen here? This might be really obvious. You might be thinking, well, obviously that's super flat. This might be a great place to go walk your dog or go for a snowshoe with kids, because when we put our inclinometer on it, we can see that indeed even the steepest slope in this picture is less than 15 degrees. So more of an obvious answer here. These folks are standing here. Maybe they're talking about if they should walk under these slopes to their left and their right, because we can see that they are slopes. And good for them, they stopped before walking under the slopes to try to decide, are these slopes over 30 degrees or not? And if you put your inclinometer on them, you'll see that indeed what we can see in the photo at least is less than 30 degrees. So this photo has some kind of obvious avalanche terrain, big steep slopes. And if we put our inclinometer on some of them, we'll see that indeed up there we've got slopes over 30 degrees, and down lower on the left, again, it's a much smaller piece of terrain, but we still have slopes over 30 degrees. And then we also have these big terrain traps where maybe if we were going to go hiking up this valley because we felt safe on flatter low angle ground down near the river, we would want to think about the terrain above us and wonder, did we read the avalanche forecast, and did they say that there were going to be avalanches big enough to come down into this flat terrain below? So just always kind of thinking about the terrain around us. We look at this. To me, this looks like an amazing place to go, and there's all different kinds of lines. I'm a skier, so I'm always looking at what I want to ski. And indeed, that ridge up there at the top, we see something that's lower than 30 degrees. It's closer to 15. That might be a great place to snowshoe up and hang out on the summit there, get some nice views. Linda, yeah, what's your question?
Can you hear me?
Yes.
Okay. So back when you were showing some of the first slides about the avalanche and the 3 parts of the avalanche, if you were a pretty good skier, if you were towards the bottom of the avalanche, I think you called out the run out, could you outrun an avalanche, or is that just not even realistic? Out ski an avalanche, you know what I mean?
Yeah, that's a really good question. So if an avalanche was coming down above you naturally and you were skiing, you could potentially get out of the way if you were able to, get some speed. If bigger avalanches like that picture you're talking about, that was a huge slide path. And once it starts thundering down, it can reach like 60 miles an hour. But if you hear it and see it, if you're down at the bottom, you can potentially scoot your way out of there pretty quick. But it kind of depends because, it depends on if you do hear it and if you can see it, for one. And also you might fall down, or maybe the ground's too flat and so you can't really move, or if the snow's really deep, you're kind of wallowing around. So I think that's a good thought to have. But I think there's a lot of variables involved in terms of the size of the avalanche, visibility, and then what kind of conditions you're in at the time.
Is there always sound with an avalanche?
They're noisy. Maybe not when they very first break and start to fall, that I have noticed can be rather silent. But then as they start to fall downhill, yeah, it's a lot of mass. They're quite heavy, a lot of snow, and if they're picking up speed as they go, they're pretty thunderous. It's funny you should ask because I actually heard an avalanche the other day that happened really nearby, and we knew we were in that spot because we knew for a fact we weren't in the run out of any avalanche paths because we expected there to be natural avalanching that day. But it was also really foggy and we couldn't see anything. But we heard it and we knew that's what it was. And it was unmistakable rumble, thundery rumble. And, there's nothing else that it could have been that made that noise. And then later the fog cleared up, and sure enough, like a few hundred yards away, we saw the avalanche debris at the bottom of a slide path.
Thank you.
Yeah. Thanks for the questions. All right. So I think we're circling this piece of terrain here because we're identifying that it is steeper terrain and there are terrain traps in there. It's treed and there's a gully at the bottom. And so just again, to say we're training our eyeballs, I like to kind of think about how we need to intentionally develop our avalanche eyeballs. So we're going out and we're looking at terrain in a new way and in a very intentional way, trying to decide if we think it's steep enough to avalanche or not. And if we don't try to train our avalanche eyeballs and see avalanche terrain, then essentially when we're going out in the snowy mountains, we're kind of going out blind. Can an avalanche happen here? You see this slope where this person's been riding their snowmobile, and they're probably making a good choice for the day because it's low angle over there, below 30. But you can see these other places where it rolls over and gets steeper, and that's probably why this person is zipping up and down on this little lower angle spot in the middle. So if after we train our eyeballs, we start to see these little spots that we're out of harm's way, and we avoid these steeper spots where we could trigger an avalanche. Okay, so that's the end of our game, our exercise. Back to the Prezi. So next we're going to dig a little bit into the different kinds of avalanches. There's basically, big picture, 2 categories of avalanches, like 2 umbrellas that most avalanches fall under. And one of them we call slab avalanches, and one of them we call loose avalanches. And essentially, the difference is that with a slab avalanche, there's weak snow that wants to fall downhill, but it's buried beneath the surface. And with a loose avalanche, there's weak snow that wants to fall downhill, but that weak snow is on the surface. So this picture in the top right is a picture of weak snow that was buried below the surface. And when it was triggered and fell downhill, it took a slab of snow that was sitting on top of it with it. And that's what we call a slab avalanche. The picture on the bottom might be kind of hard to see. We'll look at a few more pictures in a minute, but there's this kind of white streak down the middle, and that's because we had weak snow sitting on top, and that snow starts to fall downhill in one little spot, and as it pushes more and more and more snow as it goes. So let's see if we can get some better pictures here. Slab avalanches, oh, I just said this, occur when stronger layers of snow develop over weaker layers of snow and break loose from the surrounding snowpack. So remember that when we say weak snow, we're talking about snow that you could identify. I guarantee if you went outside and you found snow and you couldn't make a snowball with it, it was really dry and fluffy, you already know what weak snow is. Dry and fluffy, loose snow underneath. And then sitting on top of that, we have that stronger snow where maybe it's warmed up from the sun, or maybe it snowed and it was 31 degrees, so it piled up and it was wet, heavier snow, denser, heavier, all synonyms, strong, dense, heavier, sitting on top of that weaker, low density snow. So that's the structure for a slab. And this person here is standing right next to the crown, where when that weak snow collapsed and fell downhill, it had stronger snow on top that went with it. And when that slab pulls away, in my mind, it helps me think of a jigsaw puzzle. So if you've ever made a jigsaw puzzle, when you take one of those pieces out of that jigsaw puzzle, it leaves behind the edge of the other pieces. So it's just like a puzzle piece falling away. And that one puzzle piece falls away because that puzzle piece is in the steepest part of the slope. And what you can see in this picture is that the slope around this guy that didn't slide downhill, it's all slightly lower angle. So it didn't want to fall. Here's another good picture of a slab avalanche, also with a couple terrain traps like trees and flat ground. That this person is wallowing through the debris pile. But you can see when that weak snow fell downhill from a trigger, it pulled away like a jigsaw puzzle piece and left this crown line behind. Here's an up-close picture now, a nice clear one of that thing I keep calling a crown, which is just that feature where the avalanche pulled away. All right, so slab avalanches, strong over weak. Loose avalanches, weak snow on top. So weak, cohesionless snow on the surface starts to move downhill. And I kind of think of this, it's like, think of really cold, dry snow. It doesn't stick together. And when some of it gets agitated, there's a trigger, gets agitated, it gets pushed, a little bit of it starts to fall. And one snowflake falling downhill pushes 2 snowflakes, push 4 snowflakes, push 16 snowflakes. So we call that entraining. It entrains or picks up snow as it goes. So these loose avalanches have this very distinctive fan shape as they fall downhill. And I have been talking about weak, low density, dry snow. So there's this avalanche called a dry loose avalanche. But the picture we're looking at is actually a wet loose avalanche. So while loose is the big umbrella category, there's actually 2 kinds. And wet loose avalanches are when the snow on top starts to get wetter and wetter. And when snow gets wet, wet is liquid water and snow is frozen water. So you start getting enough liquid water in that snow that now the snowflakes aren't going to stick together anymore. So again, it's just weak. They're not sticking together because they're too wet. They cannot stick together because they're too dry, but they can also not stick together because they're too wet. So once you start to get wet snow that wants to just fall downhill, it'll push more and more and more wet snow as it goes. Another good picture of lots of dry, loose avalanches spread out across this slope. You can see that they tend to start on the steepest parts of the terrain. We can see the start zones, the tracks, and then the run out of these loose avalanches. More dry, loose avalanche activity here. You'll notice that loose avalanches, when they happen naturally, they really frequently happen. They start at trees or rocks. Very common feature. So again, two big picture umbrellas, slabs, and loose avalanches. All right, so we've talked quite a bit about avalanche basics, and now we're going to dig a little bit into how do I know if there's a risk of avalanches where I want to go. So first we'll revisit that avalanches have 3 basic ingredients, and you can find out about today's avalanche danger from your local avalanche center. So the 3 basic ingredients that we touched on before when we showed the avalanche triangle are terrain over 30 degrees, weak snow, and a trigger, which is typically a person. And again, the terrain is what we can control. Just remember that. And if we want to know how to find out the avalanche hazard for the day, we can check the avalanche forecast. And this QR code will take you to the Northwest Avalanche Center. So I'll pause for a second if anyone wants to scan that. But if you would also like to just go to their website is nicely simple. It's nwac.us. And I am about to navigate there for us anyways. So if I go to nwac.us, we end up, apparently my internet's a little slow right now. At the Northwest Avalanche Center homepage. And we have all these different regions that we can choose from to find the avalanche forecast for the day. Is there, I'm wondering where the majority of folks in this class go recreate, when you go recreate. Okay, I'm opening the chat. Everyone throw in the chat where you often go when you go out. Ooh, lots of Mount Hood. Okay. Wow, this is really fun. I should ask this every time. Ah, Wendy, thank you for mentioning that about the mapping apps. I am going to point to that in a little bit. Well, folks are from all over the country and Canada, so that's really cool. Thanks for sharing all that. From the folks that are in the zone of the Northwest Avalanche Center, I think I saw the most people saying Mount Hood. So I'm going to click on Mount Hood down here, and it'll take us to the Mount Hood avalanche forecast. And I teach down on Mount Hood all the time. I actually spent the entire month of December living and working down on Mount Hood this year. I'm back home in Yakima now, but I'll be down on Mount Hood again for 5 days this month and 5 days in February. So I'm down on Hood a lot, and I talk about Mount Hood a lot. You all have a lot of wind slab problems down there. So when we look at the avalanche forecast, I'm just going to kind of point to a couple things on this page because I want you to see how valuable of a tool it is for you to dig into in the future. And maybe many of you have read through your avalanche forecast before, but maybe many of you didn't know that there's so many ways on this page that you can dig deeper and learn more, and so that you can gain better comprehension and understanding every time you go to this page. So I'll show you a couple ways to do that. The first thing to note is that here in the PNW, they published the avalanche forecast the night before. And I saw a lot of you folks were from, I saw Colorado quite a few times. And I'm pretty sure Colorado is one of many avalanche centers that published their avalanche forecast for the day in the morning of that day. And so I feel a little lucky out here in the Northwest that we get kind of a preview the night before. But what you want to remember is that this is an avalanche forecast, right? They're guessing about tomorrow, and their guesses are based on the weather that they expect tonight and tomorrow. So they're basing their guesses on guesses. And when the avalanche forecast is put out in the morning, they're basing it on the weather that actually did happen last night. So there's some pros and cons to both. The pro in the Northwest is that most of our trailheads are a 2-hour drive from most of our houses. And so if they publish the avalanche forecast at 7 a.m., most of us are already standing at the trailhead out of cell phone service at 7 a.m. Whereas out in Colorado, a lot of folks live 30 minutes from the trailhead, and or you get maybe better cell phone service up at the trailheads because there's a lot of ski areas and stuff. So anyways, note, posted in the evening for the next day. At the top, there's always the bottom line, and they generally tell you what to expect, where to expect it, and what to do about it. And if you click on, this is a spot where you can click on this little, there's so many places on here where if you hover over it, it says click to learn more. If I click to learn more, it tells me a little bit more about what that orange 2 exclamation points means. As I scroll down, oh, that's pretty. I see candy corn in store for tomorrow, where we've got considerable hazard up high, moderate in the middle, and low down low. And just note that if you go to different zones, so if you go to Snoqualmie Pass or Mount Baker, these elevation bands are very different. Mount Hood forecast to the highest elevation of any of they have the greatest elevation bands that they, so always note, because as you move through the mountains, you're going uphill and changing elevation. So you want to be really clear on where these changes happen. Like I want to be very clear on when I'm moving from low hazard into moderate hazard. Every time you read the avalanche forecast, you should click on this big blue button at the bottom that says danger scale and learn more as much as you can about your hazard rating for that day. So if I was going out tomorrow and I was going to travel through different elevation bands, I would read all about low, moderate, and considerable hazards. Because they come up with this color, you know, this is very straightforward, it's a color, but there's a lot of information that goes into that color. And the 3 primary things they think about are size, so how big is the avalanche going to be? Likelihood, so is it going to be going off naturally, or is it going to be really hard for a person to trigger it by jumping on it, right? There's this scale, and we call it likelihood. What's the likelihood of those avalanches happening? So size, likelihood, and the last one we call distribution. So does it live everywhere? Like every single steep slope out there has unstable snow on it? Or is it patchy? Is it just a wind slab living here or there? So size, likelihood, and distribution are 3 variables that play into these hazard ratings. And in order to control the terrain, choose what terrain we go into and have control over that piece of the puzzle, we want to know more about the size, likelihood, and distribution of our avalanche problem. So luckily, as we go down, they keep giving us more information. Tomorrow on Mount Hood, we expect one kind of avalanche, and there's 9 different ones that they have to choose from. Tomorrow, they only expect wind slabs. So now they're going to be more specific about what kind of avalanche we have. And if I click on it, it's going to give me more information about wind slabs. It's going to tell me what they look like. It says things like wind slabs that form over surface hoar may be termed persistent slabs, which is a whole nother problem type. So there's ways on here to learn more and dig in every time. Now we're looking at the size, likelihood, and distribution, which is what I was just saying are 3 key features. And the size on the right, small d1 to large d2, and d1 can't bury a human, d2 can. d3 certainly can bury a car, d4 can bury a house, and d5 can bury a village. So even the 2 out of 5 in terms of size can bury a human. So it's nice to know tomorrow we go out at Mount Hood, we expect the likelihood is likely, so it'd be likely to be able to trigger a wind slab in avalanche terrain up to a size that could bury a human. It's important info. And then this part where it says aspect and elevation, that's what I call distribution. And it's like we're looking down at the top of a pyramid, kind of, where, it's like the low elevation, the middle elevation, and the upper elevation. And so what this is telling us, where it's grayed in, is the middle and upper elevation bands. So what this distribution rows is telling us is that we shouldn't be surprised if we find wind slabs at middle on any aspect of the compass at middle elevations and upper elevations tomorrow on Mount Hood, which explains why the hazard rating was low, because they don't expect wind slabs down low. They expect them at middle elevations and upper elevations. And this is also telling me that the higher up in elevation I go, probably the more likely I will be to trigger it, and potentially the bigger in size they'll be. So they're trying to arm us with information that helps us make a plan to move through the mountains and avoid the avalanche problem. There's always at least one paragraph that's going to, again, arm us with more information on how to find wind slabs, what they look like, how to avoid them. Pictures are always worth 1,000 words, right? So I always look at the pictures and they show us what to look for to show us signs of instabilities. And here we see these shooting cracks and kind of slabs breaking off. So they're telling us if we see that, move out of that terrain quickly and go to lower angle terrain. As we go down, the last thing we see, it's always the forecast discussion. And this is an important spot to read through in detail, because this is where we're going to learn how confident the avalanche forecasters are in their forecast. So you might read everything we just looked at and think, okay, great, I'm armed with information. I'm going to go have a good day in the mountains and avoid avalanches. But then you get down here and you start to read through this forecast discussion and you start to realize, wow, they were forced to cram a lot of really complicated information into these neat little boxes. And it turns out when you read the forecast discussion, they're actually saying, we aren't really sure what's going on out there. We're confused. We don't have enough information, et cetera, et cetera. And so when you read this forecast discussion at the bottom, this is really often going to help you drive your confidence. Like, do I feel confident in my plan tomorrow? Or should I approach with a lot of caution because the forecasters weren't very certain? So the last thing down here we have for the avalanche forecast is pictures. And like I said, pictures speak 1,000 words. So you always want to click open every picture and read the caption. Their entire lives and passions and livelihoods revolve around helping you avoid avalanches. And every day they create this forecast for you. So, someone said the other day, I thought it was a very powerful statement. You are doing yourself a disservice if you are not arming yourself with all of the information that you have at your fingertips before you enter the wild, snowy mountains in the winter. And so this is the place we come to get all the information that we can to move through the mountains with a higher degree of confidence that we'll come home safe each day, and we'll read the whole forecast.
Got a
Then,
couple of questions in the chat about the forecast.
okay,
The first one is, do they ever change it in the morning if the weather is totally different than expected?
that is an incredibly good question, and the answer is yes. And it's not super common, but they a few times a winter, a handful times, half a dozen, I don't know, they will update the avalanche forecast in the morning if the avalanche hazard is going to be higher than they expected because they had very different weather. And when that happens, my understanding is that they're trying to do things very uniformly, and that at 7:30 a.m. they will update the avalanche forecast. And at the top of the page here, you'll see a big red banner across the top, and it will say something like, attention or warning, this avalanche hazard hazard for today has been increased, or the forecast has changed. And this might be a really good reason for you to want to join NWAC as a member. It's $30 a year, totally worth it. And you will also get an email that morning if you're on their mailing list that will say, warning, the avalanche hazard has changed for the day.
Second
Oh, what?
question
Yeah.
about the forecast is, how do you interpret that based off the base elevation? For example, if the trailhead is at 9,000 feet. And Stephanie, if you want to jump in and maybe if I got it wrong, just let her know.
Yeah, no, I just was wondering, like I was trying to interpret like lower elevation. I mean, I live in Colorado, like a good percentage of folks on this live training, and just was wondering, like obviously like familiar with trails, I get the 30 degrees and plus like more at risk, but I just was wondering, like, I mean, for a lot of the trails that I go on for snowshoeing, I don't know, it's anywhere from like starting at 8 to 10,000 feet. And I just was wondering, obviously you're paying attention to the degree, but I was looking at the aspect elevation aerial view. I just was wondering if it is talking about like how do you do the math? Like obviously it doesn't have to do with how much elevation you're climbing for the trail, but I don't know if that makes any sense, or maybe I'm overthinking it.
So, well, one thing, I'm not sure if this is answering your question or not, but one thing is that, these are the elevation bands for Mount Hood. And if you're looking at the Colorado Avalanche Center, they're going to have different elevation bands for where you are that
Got it. Okay,
correlate,
yeah.
yeah,
Okay. Yeah,
to
I'm
your
familiar with the
trailheads.
website. I need to probably explore it more. So, okay.
Yeah. Yeah. So, for example, these I'll zoom in a little bit. These elevations are for Mount Hood specifically. And if we were to open up Snoqualmie Pass right now, you would see that at Snoqualmie Pass, they only forecast for up to a maximum of 6,000 feet in elevation. And they start at 2,500 feet is the minimum. So these elevation bands are totally different everywhere you go. And it has everything to do with the the common trailhead elevations, the most frequently recreated in elevations, and things like that. So in Colorado, you'll see, the higher elevation bands for sure.
Okay. So it sounds like the aspect elevation, like that's one of the many elements that I should pay attention to based on the location of where I'm headed. And then
Exactly.
usually those updates break that down. Like this is an example of Mount Hood. So got it. Thank you so much.
Yeah, no worries. Yeah, tomorrow, if we wanted to go out and have a good day on Mount Hood and just say, you know what, we want to just not even have to think about avoiding the the avalanche problem, we just want to go play around and stay in this low hazard zone, we would go recreate between 35 and 5,500 feet in elevation, because that's where they're saying the hazard is low, which doesn't mean zero, but it means like very, very low. So yeah, were there other questions? Okay. Thank you for the questions. So at the very bottom of this avalanche forecast page, we'll see the weather forecast for Mount Hood, and says the weather forecast for tonight and then also tomorrow. And remember, all avalanche hazard is created by the weather. And also, when the avalanche hazard goes away, that's also because of the weather. So over time, your goal should be to get really familiar with the different problem types. For example, tomorrow they expect wind slab. Well, fun fact, you have to have wind over 17 miles per hour for it to be able to blow snow through the air to create a wind slab. Once you start getting speeds over 25 miles per hour, you don't expect wind slabs just on the other side of ridge lines, but also further down the slope now, because those are strong enough wind speeds to just distribute those wind slabs even further and wider. So that is one of hundreds and hundreds of little things that over lots of years of going out and practicing, learning about your problem for that any given day, you'll learn about these different problems. They all have their own little personalities, where they live, how they form, how they go away, how they are most easily triggered, things like that. So we'll read about the weather, and all I'm going to say is that this person that wrote it for tomorrow, his name is Robert, and he looked at like 15 different weather models. Okay, so if you go to NOAA, which is weather.gov, they use one model. If you go to mountainforecast.com, they use one model. If you go to weather.com, they use one model. All of those weather forecasts are generated by a computer that is using one computer model to generate that forecast. So don't go to your handy dandy go-to favorite weather forecast when you're going out in the wintry mountains. Use the NWAC weather forecast. Use this forecast. This forecast was written by a person that looked at 15 different weather models, a lot of them not even available to the public. They used their interpretation of that information to write the avalanche forecast. So if you're trying to properly set yourself up to go recreate in the mountains and be like, well, tomorrow I expect it to be sunny and dry because that's the weather forecast on NWAC, and the NWAC forecasters said that, we had a low avalanche forecast. Well, if it's stormy and snowy, then obviously that doesn't align, and you're probably going to be like, oh, things are happening we didn't expect. Let's stay out of avalanche terrain. So just to reiterate that, not to like hit it too hard, but this is the weather forecast where you should be getting your weather data from when you are arming yourself with information to avoid avalanches and using the NWAC forecast. You also need, Molly, I see your question. I'll get to in just one second. I also want you to know that the next time you come to read this weather forecast, click on every single one of these information buttons, because it will help you understand what they are telling you and why they are telling you that information. So dig deep. Yeah, Molly.
Oh, I was just wondering if, like on this forecast here you see on Friday, it looks like the winds are going to be pretty intense on Mount Hood on Friday. So would it be pretty safe if you're trying to extrapolate and like plan for a couple days in advance? Would it be pretty safe to assume that there's going to be a lot of wind slab danger on Saturday because of the heavy winds on Friday?
Yeah, that's a really good question. And the answer is yes. And another thing about the personality of a wind slab is that once a wind slab forms, if it's not continuing to build and get bigger, if it's continuing to build over days and get bigger, then the problem is getting bigger. But if the wind turns off, that problem starts to go away. over time. It'll slowly become more stubborn and harder to trigger. And for wind slabs, that usually takes about 5 to 7 days. For example, with storm slabs, that takes 24 to 48 hours. So a little insight into how these different kinds of problems have different personalities, and good question, because with wind slabs, it's, often up to 5 days or a week before that problem is totally gone.
Does that also depend on like how quickly the snow strengthens up? I mean, it must, yeah.
Yeah, that's the perfect question. That's exactly what it's doing is over time, that wind slab is bonding to the snow below it. And so that weak interface is going away. And that can happen more quickly if it, rains or gets really hot out or something. That might cause some wind slabs to release naturally, but it also causes the rest of them to maybe heal more quickly. Yeah, whereas if you just have kind of like calm wind, but maybe cold weather and clouds, then those wind slabs will take a little bit longer to go away. Yeah, those are awesome questions. And we could talk for hours about all the different little personality traits of all the different problem types. So I think your head is in the right place. All right, so that's kind of the avalanche forecast, and I highlighted hopefully highlighted just so next time and every time you go to read this, you'll see how you can learn more and dig in a little deeper than just reading the obvious text. But also know that they have in their menu here a lot of resources that you can dig into, including you can go to the weather station information and look at what weather has happened at all these different weather stations across the Northwest. You can look at recent observations of avalanches and other things submitted by the public. So I encourage you to spend a lot of time digging in to the NWAC website if you're in the Northwest or wherever you may be, Canada or Colorado, and digging into your local avalanche center. Out of the 23-ish avalanche forecast centers in the United States, somewhere around 18 of them use this exact same format. If you're in the Wasatch in Utah, you'll notice that they use a different format, and they use 7 avalanche problem types instead of 9. So there's slight differences, and especially I have not honestly dug into a avalanche forecast center in Canada yet myself, but I'm sure yours look slightly different, but generally speaking, we all speak the same language, the way we talk about them. So. All right, so to continue along here, we will skip the questions. Zooming back out, we were checking the avalanche forecast. We learned how do I find out about the dangers of today's avalanches. So you're arming yourself with information of what to expect before you go outside. But once you get outside, things might be different than you expect. And there's a small list of things that we call red flag warning signs that you should always be on the lookout. No matter what weather you expect, always look for these things because they're all signs that the avalanche forecast is either elevated or it's elevating rapidly. And the first one is wind. And so if we see snow blowing in the wind, it's likely that wind slabs are forming, right? Here's some good pictures of wind blowing off ridge lines. Visible signs of snow blowing through the air, we know wind slabs are forming. If we have warming temperatures, so be aware of warming temperatures from overnight to the next day or from the morning to the afternoon. Rapid warming can increase the instability in the snowpack. So rapid warming, that could be from sun or temperatures or rain. Here's a pinwheel or roller ball that happened from rapid warming and the snow is really wet. That's a huge one, size of a snowmobile. Signs that snow is wet. We have warming, you might see dripping off of icicles. You might see rain, runnels, or even liquid water. So, this might make you not want to get out of your car, but trust me, it's always worth it. So you see moisture, rapid warming is a red flag warning sign. And the next one is heavy snowfall. And we define heavy snowfall by 1 inch per hour or 24 inches, or 1 foot over 24 hours. That is a great indication. If you're ever out in conditions like this, lots of new snow, you probably have a storm slab, or you could very well have a storm slab problem or a dry loose problem. So heavy snowfall is a indication that there's potentially an avalanche hazard. Cracking, collapsing, also called whoomping, which is a sound whoomp, that you hear when you triggered a weak layer and the slab on top of it falls and it's forcing the air out from underneath. You might feel a distinct settling beneath your feet, hear a whoomp sound, and these are indications that there's definitely an instability. There's a weak layer in the snow, and you should stay out from avalanche terrain and out from below the run out of any avalanche terrain. There's a good picture of what they mean by a shooting crack, shooting out from the tip of your ski or snowshoe or snowmobile. Another shooting crack. All right, and then lastly, we have recent avalanches. If you see debris, crowns, or watch an avalanche happen, obviously there's an instability in the snowpack, and you should certainly stay out of avalanche terrain and out from below avalanche terrain. So there's a picture of a very large recent avalanche. So we arm ourselves with the weather forecast, but we're also looking for these signs as we move through the mountains. All right, zooming back out. The last two here are how do I avoid avalanche terrain and what are my next steps? And don't worry, I know it looks like we still have 50% of the presentation to go, but the vast majority of this presentation is tied up in these first two bullet points. So when we get into how do I avoid avalanche terrain, the only way to completely eliminate it is to stay away from steep snow-covered slopes. But there is a basic process for avoiding avalanche danger. So if you're interested in going on a snowshoe where you're traversing a steep slope or going out skiing and you want to ski down some steeper terrain, the basic process can include looking at maps ahead of time to make sure that you know before you even leave the house whether or not you're going to be anywhere near avalanche terrain. So what does it look like on a map? There's a lot of maps out there now that a lot of different mapping apps. I feel like every time I turn around, there's a new good mapping app. But some of the most popular ones are called CalTopo, CalTopo. Another popular one is called Gaia, Gaia. And another really popular one for winter backcountry is called Onyx, ONX, Onyx Backcountry. And on all of those mapping apps, they all have an app for your phone and also a desktop version on your computer, or a website, I should say. They have this ability to turn on this function. So when you're looking at a slope, a map, a topographic map, like the one we're looking at here, when I turn on what's called slope angle shading, you see all of these beautiful colors appear: yellow, orange, pink, and purple. And yellow is terrain that's 27 to 29 degrees. So just below that threshold of what we call avalanche terrain start zones. Orange is 30 to 34 degrees. And red is that magic number, 35 to 45 degree slopes are red. So this isn't 100% accurate. It's a computer algorithm that's based on topo lines that were mostly made from LiDAR from a plane flying around in the mountains, right? So there's a lot of room for error on a step-by-step basis as you move through the mountains. But it's a really, really important way to get a big picture idea of what kind of terrain you're going to be near when you go outside. So here on the right, it shows that scale I just described, yellow, orange, and red. And there's a couple more maps here, like on a day with a higher avalanche hazard, it might feel like you can't figure out where to go in a place like this to avoid the hazard. There's just a lot of steep slopes and big terrain. Whereas if I look at this map, I might notice that all these red dots here, these snowshoe trails, there's not a lot of big avalanche terrain above it. There's a lot of big avalanche terrain over here, but if I'm on these snowshoe trails over here, I'm separated by lakes. I'm on the other side of these lakes from that avalanche terrain. So maybe on a day, even with, you know, a considerable hazard rating, I might be willing to go poke around on these trails and again get on the ground visuals to make sure I'm avoiding anything above me as I go. But hopefully you can see how this is an important tool to use ahead of time before you leave the house to preview the terrain that you are potentially going to expose yourself to when you're in the mountains. All right, zooming back out, our basic process for avoiding avalanche danger includes assessing, planning, and reflecting. So assessing is getting all that information. Like I said, you know, don't do yourself a disservice. Instead, get all the info you can before you leave the house. Use that information to make a plan that makes sense based on the information you have. Go out, execute your plan, and then at the end of the day, reflect and think about, you know, how did we do today? Did we avoid the terrain we intended to? Did we see red flag warning signs? If we did we dial it back and move into lower angle terrain? So this assess, plan, reflect every day. Assess, plan, reflect. All right, zooming back out, now we'll move a little bit into what some next steps might be for folks in this class. And we'll talk about what gear should you carry, what other skills might you need, and then we'll wrap up the presentation with some questions, if there's any remaining questions. So when it comes to what other skills do I need, you might fall into one of these categories. You might be sitting here thinking, I want to go play in the snow, but I just want to avoid avalanche terrain. I don't want to do all that extra legwork to figure out what kind of problems we have and where they are and where they aren't. And that's great. You might also be sitting here thinking, I want to engage with it. I want to go on longer snowshoe hikes that might cross avalanche paths, or I want to go up a ridge and ski down some steeper terrain, you know. And also your attitude or your perspective on this might change from day to day. Some days you might fall in one camp and some you might fall in another camp. So I'm going to just give you a list of suggestions for other future education and skill sets that you want to pursue, regardless of which of these two categories you might fall into. So to start, you want to, regardless of, you know, you want to avoid avalanche terrain, well, you need to still be able to identify it, because you can't stay away from something if you don't know what it is. So that practice we went through of looking at avalanche terrain on maps ahead of time, and then developing your avalanche eyeballs as you go outside, move around through the hills, just make that a practice and try to get better at figuring out where it is. Reading maps. So that map that I showed you, those apps, CalTopo, Gaia, and Onyx that I listed, learning how to use those to navigate and move through the mountains. At minimum, basic first aid and CPR, so that if anything happens out there, you know, you're in the backcountry, you're in the wilderness, but not only being able to provide first aid to somebody, but remember that you're in the wintry mountains. So in the summer, if someone twists an ankle, it might be easy to sit there for 6 hours to wait for help, or even spend an unplanned night outside. But in the winter, you need winter travel skills and safety. So you're 2 miles from the trailhead and someone twists an ankle, you might not be able to get back to the trailhead that day, and you might spend an unexpected night outside. So just thinking about what gear you're carrying, how to dig a snow cave, how to maybe think about different equipment to carry, like a small stove or maybe a small bivy sack. So just thinking about winter travel and safety skills in general. Even if you're trying to avoid avalanche terrain, you're still out in the wintry mountains. So thinking about other events that could go wrong and how to mitigate those. If you're interested in engaging with avalanche terrain, maybe riding steep slopes on skis, a split board, or a snowmobile, or you have winter mountaineering objectives. And honestly, even if you have spring mountaineering objectives, it can be absolutely stormy and avalanche hazard and wintry in the mountains in the Northwest until June or late June some years. And so not only in this case, do we have all the skills I just mentioned, but we are going to add to that list group management and communication. And in fact, they've studied hundreds and hundreds of avalanche accidents. And it turns out that on almost every single avalanche accident, at least one person in the group said, I had a really bad feeling. And either they didn't speak up or they did speak up and nobody listened. So this communication key piece, in addition to identifying avalanche terrain and knowing the avalanche forecast, is the number one way that you can avoid avalanches in the future, is by choosing your partners, choosing to go out with people that are willing to speak up and willing to listen to you when you speak up. And then additionally, learning skills and techniques for facilitating these conversations in a very systematic way. And so what I'm alluding to is what we call the recreational level 1 avalanche class. And in Canada, they have a 1-day avalanche class is the level 1, I think. And then if you go into the level 2, it's a multi-day class. But here in the United States, our level 1 avalanche class is a 24-hour class. And so it's with most companies, it's like 8 to 10 hours of online learning on your own, self-paced. And then you go spend 2 entire days in the field. And the number one thing that you focus on is this group management and communication component. In that level 1 class, there's also a few hours getting to know how to use your avalanche beacon and practicing rescue. But there's also a separate class that's one entire day of avalanche rescue skills. So it's instead of 3 hours of rescue that you get in the level 1 class, if you take the rescue class, it's an 8-hour day of rescue. So 2 separate classes, very different objectives, both very valuable. Another skill is really taking the time to learn how to understand the avalanche forecast. Like we just looked at it together, but as you can see, that page is very, they're trying really hard to put a lot of complex information into a small page. So really knowing how to dig in and interpret what they're talking about. And then lastly, the risk management process, which is a component, again, of the avalanche level 1 class that I've mentioned. Here in the Pacific Northwest, when we talk about the level 1 avalanche class, a lot of people just say the AIRI class, because AIRI is an organization that develops avalanche curriculum, and that's what I teach most of the winter. But that's only because AIRI teaches in the Northwest. AIRI is they've done a good job at becoming synonymous with avalanche education. But if you find yourself out in Colorado or in other parts of the country, you might hear or see more level 1 avalanche classes available through organizations such as the American Avalanche Institute or the Silverton Avalanche School, or some places like Colorado Mountain College. So there are other organizations that deliver avalanche curriculum. But if you're like me and you're here in the Northwest, most people just call it AIRI. They call it the AIRI level 1. but there are other curriculums out there. All of these curriculums are certified by one organization. So they're all good, they're all valuable, they all have a national oversight into the curriculum that they deliver. And so they're all just doing their best to deliver that curriculum in a way that works for them. All right, we're zooming back out. Here we are in our last little component here of the evening. We talked about taking a rescue class, and the three pieces of gear you'll learn how to use in that class are a transceiver, which is also commonly called a beacon. So a beacon, a probe, and a shovel. There it says, also called a beacon. It's to find the general location of a person buried. The probe is to pinpoint and actually get a probe strike on the person that's buried under the snow. And then the shovel, this is the hardest part and takes the longest and requires the most practice to get the person out. So an avalanche rescue class, well, that 8-hour class I was talking about will at minimum teach you how to rescue somebody if you're in an avalanche. But then the level 1 avalanche class is intended to teach you how to not be involved in an avalanche accident. Zooming back out. All right. So I wrapped it up. How did I do? An hour and a half. I lied a little bit about the time. Sorry about that. A little longer than I expected. But now I would just love if anybody has any lingering questions or even just comments that they'd like to bring up here in the group. I am all ears.
There were a couple questions in the chat. First one would be, oh, I gotta scroll backwards apparently. Do you know of any avalanche trainings for Nordic touring skiers? Everything I've looked into requires downhill touring.
That's a really great question. And honestly, most of the avalanche classes that I know of are also open to snowshoers. So I teach a lot of the level 1 classes when we have skiers, splitboarders, and snowshoers together. Personally, I appreciate classes where the skiers and splitboarders are in one class and the snowshoes are in another. It's totally works, and I've done it many times to have them together. But if you were interested in learning avalanche safety for Nordic skiing, I think a great option for you would be to take an avalanche class on snowshoes, because you could go out and move through terrain and look at terrain and have a way to, we call them flotation devices. You'd have flotation devices on your feet to achieve all the goals in the class. And then you could take that knowledge and apply it to whatever sport or activity you're into.
Next question. If you hear whumping, turn around and go back the way you came?
If the way you came is not steep or below steep, because that whumping indicates what we call a persistent weak layer, which is an extra scary kind of fragile weak layer that can cause what we call remote triggering, where you could be walking on flat ground, but you're actually triggering slopes above you. So you could still be the trigger, but if you're below a steeper slope, it could come down above you. So if you came in on a route that avoided avalanche terrain, by all means, that would be a great way to go back out. But it is possible to walk in and not trigger something, but walk out and trigger something even in the same exact place. Like you can trigger it later. And in fact, if you're one of the folks out in Colorado, this is a common problem in that climate where you often get persistent weak layers in your snowpack. And sometimes 50 people will ski one slope and it's the 51st person that just kind of magically triggers that weak layer. So when you hear whumping or, when you hear whumping, that's an indication that you have a persistent weak layer and you definitely want to do what you can to avoid being in or below avalanche terrain.
And then do these maps, I'm assuming she's referring to like CalTopo and Gaia and Onyx, include avalanche runout? My guess is no if they're based on terrain.
They don't. They just show you the slope angle of the slope in that spot. And so it takes actually quite a bit of skill and practice to start tying in the avalanche size that we expect. Because if we expect small avalanches, even, avalanche forecast says D1s, even in the biggest slopes, we wouldn't expect avalanches to go very far. But let's jump and say we expect D3s. Well, now we might have avalanches running out of some of that really big terrain and running quite far down into lower angle terrain and into flat ground. So one of the things that we're trying to do is identify with those maps is identify the start zones, which is 30 to 45 degree terrain where avalanches like to start. But we also have to read the avalanche forecast to think about size. And as we start to poke around in the mountains, if we are really unsure of how far an avalanche can run, we just want to build in a really big margin for error. And what I mean by that is physically put more space between you and where you think that avalanche might stop.
We've got a couple people asking if the recording will be shared, which is more of a question for me. The recording will be available just for the ambassador team. I will say that NWAC offers these sessions throughout the year through a bunch of different organizations. I think I took one myself like 3 or 4 years ago through, I want to say Oregon Hikers. So while the recording won't be available, there are other opportunities to attend these sorts of sessions through NWAC. Anna,
Yeah,
Jean,
they have a
Sure.
calendar on their, I'm looking it up right now. They have a calendar on their website. And, oh, yep, found it. And they're all free.
Mhm.
And I just will drop the link. All I did was Google NWAC avalanche awareness classes, and it brought me right to this link. And it's calendar and different, they're hosted by different organizations. And when you click on the calendar on one of the evenings that they're having the class, it probably takes you to that organization's website where you can sign up for the class.
Then I don't think there were any more questions, just a lot of thank yous for your time, which I want to reiterate. Thank you so much for your time, Anna. We really appreciate it. And it was very informative. I know I speak for everyone in the chat because they've all dropped it in there. But again, we really appreciate your time and thanks for hanging out and teaching us all about this stuff.
My pleasure. I'm really stoked for you all to go out and have an awesome winter.
Thank you, Anna.